All right, this is the first question that you would find in your linear inequalities section, and it is number 7, which is on page 79, and it's a lovely question. I think it's a very important question. So let's look at it. It says, which of the following best describes the solution set? Remember, linear inequalities don't just have a solution, but they have a solution set, because remember, it's a range of values. So which of the following best describes the solution set for the system of inequalities above? How can we determine solution sets? That's the first question. Well, remember, inequalities have solutions, and where are the solution sets for inequalities? Isn't it in the overlap? Isn't it in the overlapping of the shaded regions? The overlapping of the shaded regions of both inequalities? Right. Here's how you can get through this question easily. You can actually visualize it, or you can draw it. So the first step would be to make this first equation is already in the what you call the slope intercept kind of format. This is not in the slope intercept format. It is more in a kind of standard form format. So I would say convert this to the slope intercept format, where y is the subject of the formula. So I'll go on this side and I'll say 2x minus 3y greater than or equal to 12. I want to make my y. So I'm going to say minus 3y less than or equal to, what happens to the 2x if we need to take it over? To get rid of positive 2x, we have to minus both sides by negative 2x. So once I minus negative 2x, this will cancel out, and then I'll minus negative 2x on this side plus 12. I am already putting it in the format. Now we need to make y the subject of the formula. We need to get rid of the negative 3. How do we get rid of negative 3? We need to divide all sides by negative 3. Whenever we divide or multiply by a negative number in inequalities, what happens is the sign, let me change the color, the sign flips. Whenever you multiply or divide, everybody should know this because you all would have passed through inequalities before, but this is a recap. Whenever you are multiplying or dividing across an inequality by a negative number, the sign flips. So instead of less than or equal to, it's going to convert to greater than or equal to, and you're going to have negative 2 over negative 3x plus negative plus 12 over negative 3. And I'll elaborate a further. Negative 2, negative over negative comes positive, right? So it's 2/3 x, and then 12 over negative 3 is negative 4. So this is the final equation in slope-intercept format. So here we are, we have two equations. We have y is less than or equal to 2/3 x plus 1, that's equation 1. And then we have y is greater than or equal to 2/3 x minus 4. What's common about these two equations so far? The common thing is the slope. So once the slope is the same, what does same slope mean? We covered it in the video. Same slope means that the lines are parallel. Very important. So if I were to roughly draw this like on just out of scale, I would say my parallel lines look like this, where for one line in particular, let's say this is line B and this is line A. So I'm labeling it here, line B, A and B. Why am I labeling line A and B? Because my y-intercept is negative 4. So it therefore means that this line will cross the y-axis lower than this line because my y-intercept here is 1, right? So hopefully you all could see that. Let me just implement a little axis so at least that could help. So I'll do that. And I'll do about that. So right here represents 1, and right below here represents negative 4. And then the next step is if you all could identify where the shaded regions would be. So in line A, it says y is less than or equal to. So you all realize why I have solid lines is because equal sign is involved in the both situations. And then how do you shade? How do you add in your half plane? If y is less than, then obviously I'm going to shade below, right? Below line A. And then in my second equation, my y is greater than, so line B, because it's greater than, I'm going to shade above. So what did we say is the solution set? Where the overlapping of the shaded regions of both inequalities. That is where my solution set is, the overlapping of both shaded regions of the inequality. So where's the overlapping? The overlapping is actually between the parallel lines. Can you all see that? And this is something, once you know how to draw these two lines, you could visualize after some practice. So the first one says the system has no solution. That's incorrect. Only if there wasn't any overlapping at all, then you could say the answer is A, but it's not A. There is overlapping. The system set consists of a single point. This is incorrect because the solution set consists of a single point is only when you have lines. This is inequalities. The solution set consists of all real numbers. That's not correct. The solution set consists of all points that lie between the boundary lines. This is correct. So your answer is actually D, right? Don't mind my pen is not writing. Your answer is D because the solution set consists of all points that lie between the boundary lines. These are my two boundary lines, and all the points here would represent my solution sets. All right, so this is our number 9 under our linear inequalities section. Which of the following represents the solution to the inequality this? So you all seen a question. Remember, we went through the one-dimensional graphical representations. Look at this. This is awesome. So it says, which of the following represents your inequality? Wow. Now, isn't this a lot to digest? Look at that. What do you think you have to do? Isn't one-dimensional graphical, I'll just put 1D. Isn't 1D dealing with one variable? Let's confirm to see if we have one variable here. Yes, we do. We only have x. But in order to get the correct representation, we need to have one x. So what you all need to do, by now you should realize that you have to expand and get just x. So you have to solve or simplify, as we would say. So let's simplify it. So this is a question where they didn't just give you some x is greater than something. You have to do some work. It's not that easy. Okay, so let's do it. So it's so we expand here. So 2 times 4x is 8x. 2 times -1 is -2, greater than sign. 5x plus 13. What do we need to do? Bring all the x's on one side. So it's 8x minus 5x. Remember, when you're taking over negatives, that's subtract or addition. You don't need to flip the sign. The sign flipping is only for multiplication or division. And then what we need to do with this -2 is bring it over here as a +2. So that's 13 plus 2. So this 8x minus 5x is 3x and is greater than 13 plus 2 is 15. And we divide by 3 to get x. So you would get x is greater than 5. X is greater than 5. Once it's just greater than, it means that you have an open. So here's where we're going to use the process called PO, the method called PO, which is process of elimination. Because this is just greater than and there's no equal involved, it means that choice is A that has the solid dot goes, and choice is B that also has the solid or the closed dot goes. So C and D would be our options. Because it's x is greater than, automatically you know your answer is C. The arrow is going to point in the direction going towards the positive or towards the right side. So I am sure you all appreciated the simplicity of this question, but of course you had to simplify to get x. It's not always as simple as that. They have to make you work for it. All right, what I love about these questions that I chose under the performance section is that it allows you all to see the use of theory. So everything we would have gone through in the theory videos, you all are seeing where we have questions where you don't even have to do calculations. All you need to do is be able to know and relate the theory. This is it. That's why I'm telling you all, everything we do, make sure you have the theory. Which of the following best describes the graphical solution to the inequality? So instead of them graphing it and giving you graph choices, what they did is word it. So you have to have this down. That's very important. So this is your inequality. Y is less than minus 2x plus 3. Okay. So the first thing you all should note, because it's a less than sign and it does not entail any equal, you know that your boundary line is going to be dashed. So what you would do, so usually what you would do is you would look at it, because this is a two variable inequality. Once it's two variables, x and y, then we're talking about the two-dimensional graphical representation, which has, so the 2D graphical representation, which has what? Boundary lines and what? Half planes. Good? So right away, because it's a less than sign and it doesn't have equal to on it, you know that the boundary line is dashed. So if you were to scroll down, you would see boundary line, you would see dash, 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 solid. So here's where you can use PO, process of elimination, and get rid of D, because D has nothing to do with it. The next thing is look at your gradient. Your gradient is minus 2. Sorry, your slope. Let me use the term slope. If your slope is minus 2, this means that your slope is negative and therefore it is falling. It is falling downhill. So it's a fall. I'll just put downhill or fall. So look at this, a boundary line that rises. So right away, get rid of this, rising. That's not good. That's for positive slopes. A boundary line that falls, a boundary line that falls. So we come down to two choices. Let's look at it. A dash boundary line that falls from left to right. So we have that, a dash boundary line that falls from left to right with shading in the half plane below the boundary line. And the difference with this one is with shading in the half plane above the boundary line. Because it's less than, isn't it going to be below? So automatically your answer is B, with shading in the half plane below the boundary line, because it is y is less than. Once it's less than, your half plane, your shaded region will be below your boundary line. And that's it. That's it. So please, I want to reiterate, ensure that you have your theory down and you would have took relevant notes from those previous theory videos. Awesome. When you hear me say awesome, it means that the question is truly awesome. So I love this question. This is question 13. So it says the figure above shows the solution for the system of inequalities, and these are they here. Y is greater than minus x minus 5. Y is less than 2x plus 3. Suppose AB is a solution to the system, right? So suppose this point AB is a solution. Why did they say is a solution and not is the solution? Remember, inequalities has sets, is a set, is a set of solutions, right? Set of solutions. So inequality has several points within the solution sets. Remember, inequalities is about a range. And where do you find the solution set of an inequality? In the region where the overlapping takes place. So what I want you all to do is, remember I always say to find the overlapping region, very easy. Always find the overlapping, always find the point of intersection for the two lines, and then use that as your steering wheel in order to find the shaded region. So all here, right here, between these two lines here, here and here, in between this, all of these points here represent your solution sets, right? Represent your solution set. So here's the question. If AB is a solution to the system, right? Suppose AB is a solution to the system, if a equals 0, what is the greatest possible integer value of b? Okay, let's find a is equal to 0. Isn't a the x value and b the y value? Exactly. So where is x equal? A is equal to 0 basically means it is on the x-axis and it's equal to 0. Right here at the point of origin. Right? So how would you find the greatest possible integer? So if you move up, all these are points within the solution set here. This is a point and this is also another y point, but this right here is your highest. It is your greatest possible integer value for b, because we could have used any of these values between here, but what they're asking for is the greatest possible value. So it's the point where we stop in, is the greatest possible value. So within the shaded region, we are looking at the value is going to be just below 3, because on the line, no, I think the line actually crosses past 3. So you would get a value of 3. So you're going from 0 and you're moving all the way up. And I believe if I'm looking at it properly, 1, 2, 3, it actually passes through 3 as I look at the paper. So the greatest possible value we would go with is 2. Let me just erase this, is 2.99. So it's going to be, ooh, and they said integer. So this is very important as well. Why can't it be 3? Because it's not equal to 3. So as they say, the greatest possible integer, our greatest possible integer would be 2. Because if 3 is not an option, then we have to move down to number 2, and you're going to shade 2, right? So here, when you look, you would realize that this boundary line crosses the y-axis at 3, but because it's a dashed line, it means that that number is not involved in the solution, right? Because it just means greater than or less than. So therefore, it's going to be the other integer below 3, and that is 2. It cannot be 2.99 because integers do not have decimals. Good? So your answer would be 2. And that's really it. So it's your ability to be able to identify the correct things and look for the keywords. Somebody may have put 2.99 and did not realize that they were asking for the greatest possible integer. That is why I told you that you have to know your definitions, your mathematical definition. That is what will give you the edge on this exam, knowing your mathematical definitions and your theory.